A workbench is often the heart of a workshop. Ideally, it offers storage space, clamping options, and thus making work easier or even make some work possible in the first place. However, a workbench also requires a lot of space and is classically a static element, which means it's difficult or impossible to move. Because we often build very large objects in our company and space is very scarce, we do not use a workbench and work on beams that rest on sawhorses. The beams are screwed together from strips of blockboard and are therefore very light, but nonetheless very rigid. This way you remain flexible and can move your workplace around or put it away to save space. But I still miss the possibilities that workbenches offer. The beams are often too small to put your tools there, and tools fall down, and using the floor to store your tools in use is very unergonomic. As a temporary help, we sometimes use door blanks that are placed on the beams. But I don't really like this solution either, because it's just a wobbly, loose table and not a real workbench. We do have an old workbench, but it's frequently cluttered and simply doesn't offer the space you need when handling large workpieces, partly because it's in front of a wall. Clamping workpieces on beams and sawhorses is also more difficult than not. For clamping when gluing something they are quite suitable, but clamping for cutting and drilling is rather poor. If you work in a wood workshop or even as a self-employed cabinet maker, I'd like to know how you handle this. Do you still have a traditional joiner's bench? Do you use multifunctional tables on wheels, or do you also work only on sawhorses and beams? Write that down in the comments. Since the building of my Journeyman's piece is coming up, I thought I would build a small mobile work surface in advance, which can rest on the beams. I have several multiplex boards, all with a length of 1 meter and a width of 41.5 centimeters. A friend brought them to me from a construction site where they were left as waste material. They provide a good foundation for a workbench, which thus consists of several panels, so you can vary their size and store them in a very compact way. I imagine the workbench as a modular system. Several modules together form a workbench. They are connected through biscuit joints and toggle lever clamps. The toggle lever clamps should be located in a recess under the workbench, so that they don't get caught on the beams. The panels should be securely connected to the beams so that they do not slip back and forth when working on them. But because simple screw clamps protrude and would then be in the way all the time, I want to put rails on the bottom side. For those there are specific clamps that fit into the rails so they don't interfere. The plates get a 90mm hole grip, like I'm used to from my workbench, so I can use clamping elements and bench dogs, which multiplies the possibilities of such a workbench. Furthermore, the modules should get a front bend, so there are even more possibilities to clamp and fix the modules with a small vise. You can also store bench dogs there without having them blocking the space on top. In order to divide the milling and drilling into appropriate spaces, I made plans for the panels beforehand. The first step should be a groove, which is milled on the underside of the plates. For this I use a router with a 17mm groove cutter matching the C-rails. Set the parallel fence to 10 cm and off you go. I don't take away the complete depth with one milling step, but take several passes which plunge deeper and deeper step by step, so the results will be better and the milling cutter is less worn. I continue doing this until the rail is perfectly flush with the surface. One of the grooves is not milled over the whole length of the panel. This is where the vise will sit later on, and so that I don't make any dents with the rails or the hole when I clamp something, I'll leave the rest. To make sure that the rail sits neatly in the groove, I just chisel the radius left by the router. I still have this bushing from the building of my workbench and its 90mm dog holes. With it you can guide a 19mm drill vertically into a surface, just like with a drill press. The distance of the spacer does not fit the grid that the new workbench should get, so it will be relocated. In order to have the same distance between the holes, I always put a bench dog into the freshly drilled hole and set the distance with a combination square, so I could drill one hole after the other repeatable and constant distances. For the middle row of holes, I changed the spacer at the guide bushing once more. Next I added the recess for the toggle lever clamps. I had thought about making them with a router, but then I would have to make a jig, and I didn't feel like it. It would need 4 recesses. With so few you can just chisel it out by hand. For this I draw the outlines exactly and then hit them once with a chisel. This way the upper wood fibers are already cut through and you get a clean edge. Afterwards I can roughly knock away the wood in the middle, but always keep an eye on the edges and make a few chisel strikes to keep the edge clean and in 90 degrees. Since it is multiplex I cannot really tear out anything. When I get closer to the desired depth, I switch to a router plane to plane out the bottom of the blind hole and get an even depth. These were the recesses at the bottom. Now those at the back are left. I need 4 of them again, but this time I can simply saw them off and don't have to chisel anything. So again the outlines are marked and then sawed as far as possible with a Dozuki Japanese saw. The last saw strokes are finished with a Ryoba because you can cut deeper with it. The cut is a bit off course in some areas, so I chisel out the last few millimeters until all 4 cutouts are exactly the same. Then I cut out the bendings. They are going to be attached to the front of the workbench and will house a small vise. A vise is a fundamental part of a workbench, but because the workbench should be mobile, I don't want to use a massive piece of cast iron like in my workbench at home. Instead, I got myself a smaller offspring. The vise does not have the same range as the large model and comes without a quick release mechanism. And the thread and guide rods look quite cute next to the 15 kg model, but it weighs only a fraction of that and is much cheaper. The vise needs a small recess so that it can reach a little bit into the panel and doesn't get too bulky. I do this again with the router and the parallel pins. The procedure is the same as with the grooves for the C-rails. Here you can now see that I didn't have to take so much trouble with the C-rail groove because the rail can't reach in it anyway. The vise blocks it beforehand. A small piece of multiplex for support fits perfectly to attach the vise. This piece will become the bending. I drilled the holes for the vise before I glue it on, so I can use the drill press. It wasn't enough to just trace the holes directly, because I can only mark them from the back, but I want to drill from the front to avoid tearing. It is also not possible to simply flip it over because the vise sits asymmetrically on the panel, so I measure the position of the holes. Because you can only estimate the center of the hole, I measure the distance between the edges of the holes to the ground, add that together and divide it by 2, so you can find the center exactly. I should not have made the mistake and mix up the top and bottom of the piece. So I have to enlarge in the middle hole again, and because it doesn't work properly anymore, I have to mid it a little bit. It doesn't look that good anymore, but the vise fits now. And later you can't see any of the holes anyway. So now I can put the bending on. That happens with biscuit joints. I mark over the panel and the bending where they should be placed and then cut the slots for the biscuits. The blocks for the support can also be glued on directly. And I also place the vise where it should sit. Then it's guaranteed to fit later. The vise should get a multiplex piece as a clamping jaw. The jaw is pierced by the guide rods and the threaded rod, so it also needs 3 holes. The procedure is exactly the same again. Measure out the holes, mark them, drill them, find that they do not fit right, adjust the holes until they fit, put it in place and screw them tight. Due to the clamping jaw, the vise also gets a larger contact surface. During the work I got a surprise visit. The bird couldn't find its way out, although both garage doors were wide open.
Flieg schon raus. Da geht's nicht raus.
Route descriptions were consistently ignored and gentle assistance led to deviant wing flapping. After about 10 minutes of straying, he finally found the exit. However, you can overlook that.
Nein.
At least the glue was already dry and I could check if I am allowed to be satisfied. A small offset to the bottom, so that nothing protrudes. All good. The remaining bendings are still missing. Here the procedure is the same again. Mark the biscuit joints on both parts, mill, glue, insert the biscuit, put them together and clamp it together. While the glue dries, I can now screw on the C-rails. It is important that the screws do not protrude even a little bit, otherwise the clamps could get stuck on them later. And the rail behind the vise can also be screwed on and shortened afterwards. Now the biscuit joints between the panels are missing. They are mainly used for alignment. The panels are held together later by the toggle levers. The biscuits make sure that the surface is flat and that the individual parts do not shift against each other. I have placed the slots for the biscuits on all panels in the same way, so you can exchange them among each other. I also made the slots a little bit longer than necessary, so you have some tolerance when assembling the panels. The bendings now get their holes. These are of course 90mm holes. I have placed them so that their upper edge matches the upper edge of the guiding rods of the vise. You'll see why in a minute. And while I'm at it, the jaws of the vise will also get 2 holes to hold bench dogs. The holes now all have a sharp 90-degree edge. This is now chamfered. With a chamfering cutter I removed the edge and replace it with a small 45-degree edge. This looks better, it splinters less, but above all it protects the holes from being torn out during work. The top layer of veneer of the multiplex will otherwise peel off quickly if bench dogs regularly absorb shocks in the holes or clamps press against the edges. This is what the toggle lever connector looks like. I used the same one 2 years ago to connect my modular tables here in the workshop. Their construction is quite simple. With a thread you can adjust the distance or the clamping force. In combination with such a hook you can connect two parts together and release them just as fast. They fit perfectly into the cutouts I made on the backside. And also on the bottom side everything fits. The connectors always sit on the left of the panel, the hook to the right. So the middle plate can be left out if you want to only use two modules. Now the whole surface is sanded, so that no splinters or rough surfaces remain anywhere. But not too smooth, after all it should only be a workbench. All the edges should be chamfered and everything cleaned from dust. The connectors hold the panel well together, but the detachment only works well on the backside. On the bottom side, the connectors are not really accessible, and once they have tension, you can't really open them without using pliers. To fix this, the recesses get some finger grooves on the sides, so that you can grab the connectors properly and pull on the lever. For the workbench, there are now different possibilities to clamp workpieces. If a long piece is clamped lying down in the vise, you can use the front row of holes as a support stand by putting a bench dog into one of the holes. Therefore, they are on the same level as the guide rails of the vise. In this way, they provide additional support for the workpiece and prevent it from rotating. Of course, the row of holes can also be used to clamp pieces as on the surface, an example with surface clamps. This works particularly well for vertical pieces. In combination with two bench hooks, you can also use the vise to clamp workpieces lying on the surface, as you know it from traditional planing benches. For wider workpieces, you can also use 4 bench hooks. And surface clamps also work, of course. Especially the self-adjusting toggle clamps are my favorite. With these self-made bench dogs, you have a stop during machining that effectively prevents slipping in one direction without having to clamp the workpiece. This is especially useful if the piece has to be flipped often or is only machined for a brief period of time. In theory, you can also use the whole grid to mark angles. The grid should be made in exactly 90-degree angles, which means that with 2 stops, 2 parts can be placed exactly perpendicular to each other. So you could mark larger parts without needing a large square, or even cut them directly with a circular saw. And 45-degree angles work as well. But I have to say that my design does not come close to the accuracy of a CNC machine. There are some small tolerances in the intervals. So if it has to be very accurate, I should not rely on this. Parts can be separated from each other and put aside in a few simple steps. They can also be stacked, thanks to the recesses no parts protrude. And at the rear end, the toggle lever connectors are not damaged even if you put the modules upright.